example 15, the amount of money in a savings account t years after the initial investment is modeled by the function a of t equals 500 times 1.002 to the 12t power. And as I mentioned in class, this is the kind of thing that would come out of your pre-calculus formulas. We're asked to find a of 0 and a prime of 0. So we've got our function a of t is 500 times 1.002 to the 12t power. So a of 0 means everywhere we see a t, we substitute in a 0. We get 500, 1.002 to the 12 times 0 power. That's 500 times 1.002 to the 0 power. Any non-zero number to the 0 power is 1, so we get 500. And we're asked to interpret that number. So A is the amount of money, I'm assuming that's in dollars, t years after the initial investment. So that means initially we've invested $500. So we can think of this as we had a $500, and I guess we can call that a principal. That's our initial amount we invested. So let's take a look at a prime of t. So I need to take the derivative with respect to t. 500 times 1.002 to the 12t power. The 500 is a constant multiple. That come out front. So 500 times. And now I'm taking the derivative of 1.002 to the something. The derivative of 1.002 to the something is 1.002 to the something times the natural log of 1.002 times the derivative of that something. The derivative here of 12t is 12. So if I wished, I could migrate that 12 up front. 5 times 12 is 60, so that would be 6,000 times 1.002 to the 12t power times the natural log of 1.002. That would be a prime of t. And a prime of 0, everywhere I see a t, I plug in a 0. The 1.002 to the 0 power is going to be 1, and I get 6,000 natural log of 1.002. So this would represent the rate of change, right? So we could fire up Desmos to get an approximation for this. So 6,000 times the natural log of 1.002 is roughly 11.988, roughly 11.99. So that means that initially the rate of change, or the rate of, in this case, increase, because it's positive. So the investment is growing at a rate of $11.99 per year. Find and interpret a prime of 0 divided by a of 0. So a prime of 0 divided by a of 0, well, I've got those numbers here. 6,000 natural log of 1.002 divided by 500. And that's going to be 12 times the natural log of 1.002. So once again, fire up Desmos. Give me an approximation to this. Uh, 0.2397, blah, blah, blah. So this is a relative rate of change. So a prime of 0 divided by a of 0. Remember, this is a relative rate of change, or a percentage rate. But think of this as a percentage. This is roughly what? 2.4-ish%. So that says initially the relative growth rate of this investment is 2.4-ish%. Let's take a look at a prime of t divided by a of t, and we're going to see something not unlike what we saw in class. So if we look at the expression for the derivative here, 6,000 times 1.002 to the 12t times natural log of 1.002 divided by the function itself, 500 times 1.002 to the 12t. We see the same thing that we saw before in class, namely the exponential part cancels out, and we're left with the same number we had before at 0. So once again, what characterizes these exponential functions is that they have a constant relative rate of change. So the relative rate of change here is an effective growth rate of 2.4%. So even though the formula here may have come from, compounding things continuously, or compounding things continuously at a certain percentage rate, the effective growth rate here is 2.4% per year, and that happens at every single instant. So it's continually growing at that constant percentage rate. So that'll do it here for example 15.